Hey everybody, in this video we're going to be finding trig ratios of any angle. If you want to follow along, the links to the companion worksheet are in the description below. So let's get started. Now what we're going to be doing is, without a calculator, we're going to be finding all of these trig ratios. Now all of these angles are not between 0 and 90 degrees. However, they are going to make reference to other special right triangles that we have seen before. So let's look at this first one. Cosine of 150 degrees. Well, what does a 150 degree angle look like? Well, it's just 30 degrees short of 180. Now, what is this angle right in here? This is 30. So let's fit a special triangle right there. That would be 30, that would be 90, and here would be 60. So what would these side lengths be? Well, this could be 1, this could be square root of 3, and this could be 2. Now what would be the coordinates of this point up here? Well, it would be negative radical 3, comma 1. And so we want to know what is the cosine ratio here. So what do? Well, from the last video, we take the x value. So cosine of 150 equals negative radical 3, and we divide by that distance between the point and the origin, which is 2. And that's it. So what we're doing is we're drawing the angle. We're seeing what reference triangle. That's what this is called in red. And it's going to be one of two special right triangles, either the 30, 60, 90 or the 45, 45, 90 triangle. It's always going to be one of those two when we're looking for a trig ratio without a calculator. So for the second one, here we've got tangent of 315 degrees. Well, it's bigger than 90, bigger than 180, bigger than 270. So it's actually going to be somewhere in here. So here's 315 degrees. So what is this angle right here? This is 45. So when I sketch out my reference triangle, this side could have a length of 1, this side length of 1, this side a length of square root of 2. So let's see, what is this point? This would be positive 1, negative 1. And so tangent of 315 degrees is going to equal, well, we said that it's the y value, negative 1, divided by the x value. So that gives us a ratio of negative 1 for tangent of 315 degrees. Now for the next one, here we're graphing negative 240 degrees. So let's see. Because it's a negative, we go down. We rotate down instead of up. So here's negative 90, here's negative 180, here's negative 270. So we're not quite that far. So here is negative 240. We're 30 degrees short. So let's see. Here's our reference triangle. We always draw a reference triangle onto the x-axis. And so if it's 30 degrees short here, then that means this has to be 60. And this has to be 30. So what are our side lengths? 1, square root of 3, and 2. So now our coordinate would be negative 1, square root of 3. All right, so cosecant. Well, cosecant is the reciprocal of sine. And sine is the opposite, or in this case the y value, divided by the hypotenuse, or the distance. So cosecant of negative 240 degrees equals 2 over radical 3. Now if your teacher wants you to rationalize, we're going to get that radical out of the denominator. So we're going to divide square root of 3 by square root of 3. And so we have 2 radical 3 over 3. And so that is our cosecant ratio for negative 240. For number 4, here we want 11 pi over 6. Well, let's see. Forget the pi. Just think of the fraction 11 over 6. Well, that's bigger than a half, bigger than 1, That's bigger than 3/4, but it's just shy of 2. Here's 11 pi over 6. So we fit in our reference triangle right there. And what would this be? Well, it's pi over 6. Now, what is that in degrees? Well, that's 30 degrees, which means this is 60 degrees. So for our reference triangle, this is 1, this is square root of 3, and this is 2. So this coordinate down here is square root of 3, comma, -1. And so if we want secant of this angle, secant of 11 pi over 6, what do we get? Well, we take the x value, square root of 3, and divide by the distance between the point and the origin, which in this case is 2. So square root of 3 over 2. Or wait a minute, that's cosine. So actually, we want the reciprocal. So that's 2 over radical 3. And so we need, if your teacher wants you to rationalize it, well, that's the same as what's up there. So that's actually 2 radical 3 over 3. Now on the next page, here we want to find tangent of -3 pi over 4. So forget the pi, just look at -3/4. Here's -½ pi. Nope, got to keep going. Here's -1 pi. Well, that's in the middle right there. So this is -3 pi over 4. So our reference triangle is right there. So now this is perfectly divided in half. So this angle is pi over 4, or 45 degrees. And so our side lengths are 1, 1, square root of 2. And so this coordinate right here is 1, comma 1. All right. So now, if I want to find, whoops, actually, because it's in the third quadrant, it's -1, -1. My apologies. And so now, if we want to find the tangent ratio, what do? We take the y value and divide by the x value. So tangent of -3 pi over 4 is -1 over -1, which is just going to be a value of 1. All right. Now, for number 6, we have cosine of -3 pi. All right. So if we just cover that up, we just look at -3. So here's -1/2, -1, -1.5, -2, -2.5, -3. So here is -3 pi, this angle right here. Now the issue is, it's right on the x-axis. And so because it's right on the x-axis, that means that it doesn't form a 30-60-90 or a 45-45-90 triangle. So how do we deal with this? Well, what we do is we say, well, what points could be there? Well, we could have a point like -1, 0, or maybe further out, it could be -2, 0. Well, we don't know. But the advantage is, when the point falls on either the x or the y-axis, it doesn't matter which point it is. Let me explain. Let's say we chose this one, -1, 0. If we wanted cosine of that, we would ask, all right, what's the x value? -1. And then what's the distance between this point and the origin? Well, it's a distance of 1. So we would get -1 for an answer. What if we picked this point instead? We take the x value, which would be -2, and we divide it by the distance from the origin. So this is 2 units away from the origin. So either way, we get an answer of -1. And we could pick any point along here, along where that angle ends, and we're always going to get an answer of -1 for cosine. And so anytime you have an x or a y value that ends up being 0, it really doesn't matter what the other coordinate is. And so finally, for this last one, we have secant of 11 pi over 2. So that's a positive. So again, let's cover up the pi and just look at 11 halves. So 1 half, 2 halves, which is 1, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves, 10 halves, 11 halves. All right, so I'm going to end up here. So let's count this out. 1, 2, 3, 4 halves, 5, 6, 7, 8 halves, 9, 10, 11 halves. I end up here. So somewhere on here is the point that we have, but the x value is 0. Now, like I said in the last example, it doesn't really matter what the coordinate is. It could be any point along here. So we'll just make it simple and just say that the y coordinate is -1. Is it? Well, it could be. Doesn't have to be. And so if we want secant of 11 pi over 2, what we do is secant is the reciprocal of cosine. So we would take the x value, 0, and divide by the distance, which is 1 unit away from the origin. But it's the reciprocal, so we're going to take the distance, put that on top. And so this point is 1 unit away from the origin, and we divide by 0. And so this point is undefined because we're dividing by 0. Thanks for watching. If you liked the video, give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.